Okay, today we're going to be looking at our Year 13 integration involving trig functions. So we're going to start off by considering how they undo differentiation. So we know that, for example, the differential of sine is cos, so the integral of cos is sine. So the integral of cos of kx dx is 1 over k sine kx, is undoing chain rule differentiation. And so if I differentiated sine kx, I'll be multiplying by k. To integrate cos kx, I'm dividing by k. Similarly, since the differential of cos is minus sine, the integral of sine is minus cos. So the integral of sine kx is minus 1 over k cos kx. And since the differential of tan is sec squared, the integral of sec squared kx is 1 over k tan. We'll look at how to integrate tan itself later on, but those are your sort of basic ones there. You've obviously got, you can differentiate sec to get sec tan, that'll feature as well. Differentiate cosec, differentiate cot as well, they will all feature. The good news is you get a formula book, and there's nothing wrong if you can't remember every single one of these by referring to the differentiation page or the integration page and realising that all you're doing to integrate is undoing your differentiation. So let's have a look at how we apply some of these then. We'll start with integrating tan. I like writing I equals because I might have to do something or other first to my integration, my function, and then integrate it afterwards. And it reminds me I can rather than just write a random equals later on. If I write I equals, I'm going back to where I started. So I equals the integral of tan x dx. What I can do with tan is split it up as sine over cos. And I've got a function now where the top is almost the exact differential of the bottom. And because the bottom is to the power 1, I've got a ln answer here. The differential of ln cos would be 1 over cos times the differential of cos, which is minus sine. So if this was a minus, the integral of minus sine x over cos x will be ln cos. So because I've got that extra minus knocking around, the integral of this will be integral of minus ln mod cos x plus c. And that's often written as, use the minus as a power, cos x to the power minus 1, as ln mod sec x plus c. So the integral of tan x then is ln mod sec x plus c. What you'll also see with integrations involving lns, sometimes, depending on what we're doing later on, we might refer to that constant being ln c and do something else with it. Question then goes on to say, hence or otherwise do the integral of tan 3x dx. Well, all this will equal, because of the 3, chain rule, so divide by 3, and then the integral of tan, so it's ln mod sec of 3x, the function never changes there, and then plus c. Okay, so integral of tan involves ln sec, and the integral of tan 3x, I've got that 1 over 3 involved there. Let's have a look at a couple of others then. We've got a definite integral. I equals the integral between pi and pi over 4, 6 cos 2x dx. Well, let's have a look. The integral of cos involves sine, so I would write this as 6 over 2, because of 2x, sine 2x between pi and pi over 4, so 6 over 2, 3, sine of 2 pi, and then minus sine pi, sine 360, 0, 180, 360 is 0, and sine of pi, 0, 180, sorry, it's not pi, it's pi over 2. I thought it was pi over 2 there. So 2 lots of pi over 4, so it's pi over 2, that's a bit more like it now, because sine pi over 2, sine 90 is 1, so I end up with minus 3. Third example here, integral between 0 and pi over 12, 6 sec squared 3x. We've got before that the integral of sec squared is involving tan. So I've got 6 divided by the 3 because of 3x, tan 3x between pi over 12, things right this time, 6 over 3, 2, and then bracket tan, 3 pi over 12 with pi over 4 minus tan 0, and 2 tan pi over 4 is 1, so it equals 2. Tan 0 is 0. Example 4, fraction. Now, I've got a complicated thing on the denominator, But remember that because the denominator is to the power 1, I can be thinking about a Ln answer. If I differentiated the denominator, the differential of 1 minus cos 8x will be 8 sine 8x. So if I rewrote this so I've got the exact differential on the top there and dx, because I've had to split that 24 up, I'd write 3 times 8 to the 24, so it's telling me it's 3 ln mod 1 minus cos of 8x plus c. I don't think I need the mod there. I don't think 1 minus that is ever going to be below 0. It's always nice to write it just in case. And so that's that. So I'm looking, if possible, for Ln answers. I'm looking where I've got products for undoing chain rule differentiation. Like this. There we go. Flows naturally, doesn't it? So this integration here is a product. Sine 2x times cos to the 5 2x. I could do this by inspection. I know that since this is something to do with the differential of the cos function, if I differentiated cos to the power 6, give or take a constant, I've got that answer there. They want me to do it by substitution though, so we'll do it by substitution. So it says let u equal cos 2x, fine. Differentiate it, du equals 2 minus 2, differentiating cos, sine 2x dx. So the sine 2x and the dx are going to replace with minus a half du. So my integral becomes cos to the 5 2x becomes u to the 5 times minus a half du. So I've got minus a half and then integrate u to the 5 u to the 6 over 6 plus c. So I've got minus whatever u is, cos to the power 6 2x over 2 times 6, 12 plus c. And I would have got the same answer if I had just done it by inspection, by considering differentiating this cos to the power 6 2x. Well, I've had the 2 and the 6 involved in the constant there. But they want me to do it by substitution, so that's me doing it by substitution. Similarly, last example, I've got this product integrating 4e to the tan x times sec squared dx, sec squared x dx, between limits of 0 and pi over 4. Substitution again, let u equal tan x, so that will become e to the u. The du part, differentiate it, is sec squared x dx, so that's that part of the function taken care of there. And I can also change my limits. I can say x equals pi over 4, u equals tan pi over 4, which is 1, and x equals 0, u equals 0. So my integral, that's why I said write it I equals, I've done all this work in here, then my integral becomes u equals 0 to u equals 1, 4 times e to the tan x, e to the u, sec squared x dx is du, so I'm just doing that, which is 4 e to the u between 1 and 0, which is 4e minus 4 times e to the 0, 4. And that's my final answer. Because I've substituted my limits there, I don't have to undo this in terms of x and then stick my x values in. Okay, change. Every place you see, don't forget this is x equals 0 and x equals pi over 4. So change it to u equals 0 to u equals 1, function of u du, integrate it, stick your u values in, there's your answer. So be aware of products being the result of doing a chain rule differentiation. Be aware of fractional expressions maybe involving Ln answers, and also refer to your formula book if you really need it.